Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron as sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. In our previous session, we have learned that how to generate the PWM signal and how to change the duty cycle of the PWM signal using these two switches, that is switch 1 and switch 2. Here we can check on pin number 17 of this microcontroller, that is CCP1 output of this microcontroller. We have generated a PWM signal of 1 kHz frequency. Now we'll change the duty cycle of the PWM signal using the switch 1. Here we can check the duty cycle of the PWM signal is increasing. Now we'll decrease the duty cycle of the PWM signal using switch 2. Here we can check the duty cycle of the PWM signal is decreasing. Now in this session we'll convert the PWM signal into analog voltages, that is 0 to 10 volt, and we'll get feedback of the analog signal and we'll display the feedback on LCD display. Here we can find the circuit diagram of the PWM to analog converter circuit. First we'll develop the transfer circuit and the filter circuit for PWM signal. Then we'll develop the operational amplifier circuit to amplify the voltages up to 10 volt. Here we have two transistors, that is C8 to A, to develop the first stage of our circuit. And here we have 2.2K resistor to drive the base of first transistor. And here we have 47 microfarad 16 volt capacitor. We'll also connect the 10K resistors to complete the first stage of our circuit. And here we have the diode, that is 1N4148. Now we'll complete our circuit. First we'll connect a 2.2K resistor with pin number 17 of this microcontroller. And now we'll solder the first transistor in our circuit. From the top view, rightmost pin is the base, middle pin is the collector, and the left pin is emitter. And now we'll connect a 2.2K resistor between 5 volt power supply and the collector of the transistor. We have connected one end of the resistor with the collector of the transistor. Now we'll connect the second end of the resistor with 5 volt power supply. And here we have plus 5 volt power supply at this end of this resistor. So we'll connect the 5 volt power supply with this end of the resistor. Here we have connected plus 5 volt power supply to the one end of the 2.2K resistor. Now we'll connect the emitter of the transistor with ground. And here we have the ground connection, and we'll connect this ground to the emitter of this transistor. We have completed the first transistor circuit. Now we'll solder the second transistor in our circuit. The base of the second transistor will be connected to the collector of the first transistor. Emitter of the second transistor will also be connected to the ground. And now we'll connect a 10K resistor between 5 volt power supply and the collector of the second transistor. And now we'll connect the second 10k resistor with the collector of second transistor. Here we have inserted R55 in our circuit. Now we'll connect the second end of R55 with positive end of C20. Here we have connected C20 in our circuit. Now we'll connect a diode, that is D14 1N4148, in parallel to the R55. Here we have inserted 1N4148 diode in our circuit. Here we have completed the first stage of our circuit. Now we'll perform a continuity test, then we'll power up the circuit and we'll measure the voltage at the positive side of this capacitor. We have checked the continuity of our circuit. Now we'll power up the circuit and we'll measure the voltages at the positive end of this capacitor. Here we can check the voltages across this capacitor are 0 volts. Now we'll increase the duty cycle of the PWM signal. Here we can check the voltages across this capacitors are increasing. Now we'll measure the duty cycle of the PWM signal and the voltages with the help of oscilloscope. Here we can check the duty cycle of the PWM signal is slightly greater than 50%. And the DC voltages across these capacitors are 2.16 volt. Now we'll increase the duty cycle further. And now we'll check the DC voltages across the capacitor. Here we can check the average voltages across these capacitors are 3.2 volts. Now the duty cycle of the PWM signal is almost 100%. And now we'll check the voltages across this capacitor. Here we can check the average voltages across this capacitor at 100% duty cycles are 4.56 volts. Now we'll decrease the duty cycle of the PWM signal. Here we can check the duty cycle of the PWM signal is 0% and the voltages across these capacitors are 0 volt. Here we have completed and tested the first stage of the PWM to analog converter circuit. Now we'll develop the second stage of the PWM to analog circuit. And in second stage we'll amplify these voltages up to 10 volts using a non-inverting amplifier circuit. And now we'll connect an operational amplifier, that is LM358, in our circuit. And here we'll place the operational amplifier in our circuit. And now we'll connect pin number 8 of LM358 with plus 12 volt power supply, and we'll also connect pin number 4 of LM358 with ground. Here we have connected plus 12 volts with pin number 8 of LM358. Now we'll connect pin number 4 of LM358 with ground. Here we have connected pin number 8 of LM358 with plus 12 volt, and we have connected pin number 4 of LM358 with ground. Now we'll connect a decoupling capacitor of 0.1 microfarad with pin number 8 and ground of this LM358. We have connected a decoupling capacitor of 0.1 microfarad with pin number 8 and 4 of LM358. Now we'll complete the rest of the circuit. And now we'll connect a 10K resistor, that is R56, between pin number 3 of LM358 and the positive end of C20. Here we have connected a 10K resistor between pin number 3 of LM358 and the positive end of C20. And now we'll connect a 10K resistor, that is R58, between pin number 2 of LM358 and the ground. Here we have connected a 10K resistor between pin number 2 of LM358 and the ground. Now we'll connect a 15K resistor, that is R52, and 10K variable resistor, that is VR5, between pin number 1 and pin number 2 of LM358. Resistor R52, that is 15K, and the variable resistor, that is 10K, are used to provide the gain to the non-inverting amplifier. And here we have the 15K resistor. And now we'll connect a multi-turn 10K resistor in the feedback circuit. We have completed the non-inverting amplifier circuit for the PWM to analog converter circuit. Now we'll develop the feedback circuit to read the analog voltages to the microcontroller. Now we'll connect a 10K variable resistor, that is VR6, from pin number 1 of LM358 to the ground. This variable resistor is used to attenuate the voltages, that is 10 volt to the 5 volt, to make these voltages compatible with the ADC input of the microcontroller. Wiper of the variable resistor will be connected to pin number 5 of LM358, and pin number 6 and 7 of LM358 will be connected together. This circuit configuration of amplifier is called current buffer circuit. And here we can check from the schematic of prototype of RTU that feedback 1 is connected to pin number 4 of the microcontroller, that is analog input 2 of the microcontroller. Now we'll connect pin number 7 of LM358 to the pin number 4 of the microcontroller. To connect pin number 7 of LM358 with pin number 4 of the microcontroller, we will use a wire bridge. And here we have connected the wire bridge in the Vero board. We have completed the circuit for PWM to analog converter. Now we'll connect output of this circuit to the connector to interface the signal to the field devices. Here we have completed the ground path of the output connector. Now we'll connect the output of the amplifier to the output connector. Here we have connected the output of the amplifier to the output connector. We have completed the circuit for PWM to analog converter. First we'll perform a short circuit test and continuity test of our circuit. Then we'll power up the circuit and we'll adjust the output voltages of this circuit. Positive end of the capacitor is connected with 10K resistor. Okay. The second end of 10K resistor is connected with pin number 3 of LM358. Pin number 2 is connected with the 10K resistor. Second end of this resistor is connected with ground. Pin number 1 of LM358 is connected with the output connector. And the second end of the connector is connected with ground. Now we'll perform a power supply short circuit test for our newly developed circuit. Okay, there is no short circuit between power supply and ground. Now we'll insert LM358 in our circuit and we'll adjust the output voltages of this amplifier. Here we have inserted LM358 in our circuit. Now we'll power up the circuit and we'll adjust the gain of this amplifier. First we'll adjust 1 volt at the input of non-inverting amplifier circuit. Now we'll increase the duty cycle of the PWM. And now we'll check the output of the amplifier circuit. Here we can check we are getting 3.55 volt at the output of this amplifier circuit. Now we'll check the feedback voltages to the ADC input of the microcontroller. Here we can check we are getting 1.76 volt at the input of ADC input of the microcontroller. Now we'll adjust these voltages to the 0 volts. And now we'll set the duty cycle of the PWM signal to 100%. Now the duty cycle of the PWM signal is 100% and we'll check the voltages at the output of non-inverting amplifier. And here we can check we are getting 10.46 volts at the output of PWM to analog converter circuit. Now we'll adjust these voltages to 10 volt with the help of this variable resistor. Here we have adjusted the output voltages of PWM to analog circuit to 10 volts. Now we'll adjust the feedback voltages to the microcontroller. Here we have adjusted the feedback voltages to the 5 volt. And here at the output of PWM to analog converter circuit we are getting 10 volts. And we have adjusted the feedback voltages to the 5 volts. Now we'll write a program to display the feedback voltages on LCD display.